Namaskar, my dear friends. Let us talk about how we can simulate and design RC filter for high pass filter. Okay, so we are going to design high pass filter using RC element, that is resistance and capacitance element. So the basic configuration of the RC filter for high pass configuration is C and then R. Okay, so this particular source will be having like a characteristics of high frequencies, and that will only be passed. So what is the characteristics of high pass filter? It happens to be like this. So basically the frequency will be allowed after some cutoff frequency, let us say FC. So after this cutoff frequency, the all the signal will be allowed, and below this it will be cut off. Okay, so as you can see from the simulated circuit, let us say we have a circuit here, and this is the like a particular source that is there, AC source, and we have C1 and R1. So C1 and R1 value will be helping you to set up the low cutoff frequency of this high pass filter. Okay, so at this minus 3 dB, what will be the cutoff? That will be at this FC. All right, so this is the Bode plot, magnitude plot, and this is phase response of this particular RC filter design. Now to set the cutoff frequency, if you want to reduce the cutoff frequency, what will happen? You have to increase the value of R, right? And if you want to increase the value of cutoff frequency, you have to reduce the value of R. So as my R decreases, the cutoff frequency increases. So for this value of R and C, let us say 1 kilo ohm and 0.1 microfarad, what will be the cutoff frequency? So the cutoff frequency will be Fc equal to 1 by 2 pi into R is 1 kilo ohm into C is 1 microfarad. And if you calculate this, let us open quickly here. So 1 kilo ohm, that is 1000 ohm, and zero point 0.1 microfarad. So you are going to see 1.59 kilohertz, that is 159.1 hertz. Okay. So let us design this particular circuit in NI Multisim and try to simulate the AC response and see what is going to happen. All right. So I have opened a new window. You can go here and create blank and create it. So you will open a new window, right? Now very first thing that we have to do is we need one R, C and one AC source element. So for that I am going to put component, place, come to basic, put capacitors, and then place any value you can do, not a problem. And after that you can change the values, right? So put this capacitor, then put this resistor. To rotate it, right, just press Ctrl R to rotate it. Okay, then you are going to put sources, and in sources I am going to put power sources. I need one ground, so I am going to put a ground here, and then I need a signal voltage source as AC source, so we'll put one AC source. Okay, so that's all. My circuit element placement is like done. Now to wire this up, what we will do? We'll quickly wire up. So before wiring up, why don't we do one thing? We'll write a comment here. So place text, and write down HPF design and simulation, like high pass filter design and simulation. I'll change the color to, let us say, blue. That's all. To quickly wire up, I'll just go to the tip of the component and it changes into wiring option, and this is how you are going to wire up. All right. Now I am going to change the value of capacitance to 0.1 microfarad as we had designed it. So my output will be 1.59 kilohertz high pass filter. Okay. So to see that, what we can do is we can put a voltage probe here, and let us go and simulate this. So once you simulate, analyze and simulation, come to AC sweep, and here you are going to change the start frequency, stop frequency. So stop frequency, I'll just put it, let us say 100 megahertz, because we don't want to go for up to gigahertz and all. Then we will be keeping it into decade, and then vertical scale will change it to decibel. That's all. Now let us run it. So as you can see, we have this is my AC sweep, and since it is not visible, what I'll do is I'll go and change the trace width to little thicker so that you can very easily see. And this is my phase plot. Phase plot also, if you want, you can change it little thicker. Right? Now, as you can see, at 1.59 kilohertz, this is 1 kilohertz, this is 2 kilohertz. So between these 2 points, first point and second point, we will have minus 3 dB, 0 and then minus 3 dB, right? So if you want to see that, what you can do is right click it and show cursors, okay? Show cursor. So cursor will be shown, and here you are going to bring it. So you can see this should reach to minus 3 dB. So you will have a cutoff frequency this much kilohertz, okay? So I will increase little more. Yes, 2.97 almost 1.6 kilohertz or 1.59 kilohertz. This is how it is changing. All right. Now, what will happen as my resistance decreases, my cutoff frequency can increase, right? So if I want to increase the cutoff frequency to some more, like higher frequency, what we can do? We can reduce the resistance value. So to reduce the resistance value, just double click it and let us say instead of 1 kilo ohm, I'll put 100 ohm. So 10 times it has decreased. So the cutoff frequency will become 15.9 kilohertz, that is 10 kilo ohm, 10 kilohertz, 20 kilohertz. So between these two, my 3 dB will appear. So you can see here y2 is minus 19. Now it will become minus 3 dB at this point. See. So it is going to be around 15.9 kilohertz at 3 dB, right? So this is how you design and change the cutoff frequency for your high pass filter design, right? So this was a very simple circuit. If you want, you can vary your input signal source as well. Like right now I have taken it for 1 kilohertz. If you want, you can keep it 10 kilohertz signal, okay? So this is my 10 kilohertz, and if you want to see the characteristics of this particular AC signal, you can come put a voltage probe here and run it, and let us see what it says. You have to actually change it to simulation in like normal mode. So let us say I'll put it in transient mode and change it to, let us say, okay, 1 millisecond is enough, okay, and let's run it. So you can see we have very nice AC signal of this particular output. So trace width I'll increase. So you can see my output is plus minus 1 volt peak, right? So 1 volt peak, 1 volt down, right? And this is the time span, and this is my magnitude span. So alright guys, hope you have a good understanding about how to design and simulate high pass filter using RC element in National Instruments. Thank you so much. Bye.